Alright, hello and welcome to this episode of the BC coding stream. I hope that various sound problems are solved now. If not, let me know in the chats or anywhere. I try to monitor everything as possible. So yeah, this time I'm looking into picking up my how-to videos again, but in the style of the live stream like I used to before, and I think I've now know what the problem with my audio was. I think now it should be better. Something like this. All right. And this time I want to look at how interfaces work. I feel like there is still some confusion around interfaces and how to make use of them, how they can benefit us and like developers in general. And yeah, let's have a look at them. So first of all, let's get rid of that hello world thing here. Let's delete it altogether actually. Right, don't need this, and let's create a new file. Let's start with a code unit. I think code units are, yeah, should be clear for everyone. So, thinking about a use case, what we can use to do interfacing, and I think I will use the well-known example of vehicles. So let's imagine we have a car, just a car code unit, and this might be something that's like it tends to go into a direction where it looks like a class kind of thing, but we don't have classes in BC, so just stick with me for a minute. So imagine, and Copilot is already doing funny things here. Let's imagine we have a car, and a car can something like this, get a car model. And let's not call it like this, let's call it get model. And let's do something like drive, which doesn't return anything. And let's do something like, okay, stop maybe. And well, park is not really good example. Let's stick with this for now, or maybe get procedure, get number of wheels. That's also a good thing. Now, if we want to, let's see, how can I explain this the best way? Let's rename the file for now. The easiest way to explain this, first maybe get into interfaces. Let's create an interface, the interface, and this would be vehicle. And if I now say that any vehicle can do those things here, can do whatever we want to do here. And actually, before we manage the interface, let's first call this. And now I've deleted my perfect page extension to test this, so I'll need to recreate it. That would actually have been nice. So let's just recreate the hello world example. Just to test around a little bit. Okay. The action, and this will just be a test one. And area. I was wondering what I'm doing wrong here. Processing. And not this. It's Sunday. My brain is not up to speed yet. So this should work. And we need an application area. Okay, missing caption, but we don't really care. All right. So now if I am using my car code unit and I just want to message format car get number of wheels. Let's actually return something. And let's, I mean, do I need to run this? I mean, this is pretty obvious. I'm just returning whatever that function gives me. And I mean, there could be logic in here. I mean, it's just an example. Now, if I want to also support, for example, motorbikes, let's copy the car code unit and say this is a motorbike. Obviously need to rename this. Now I have cars and motorbikes, and now I want to get the number of wheels here, and we have 2 wheels, obviously. Otherwise it wouldn't be a motorbike. Now, if I want to support both options, I would probably start to create an enum, then do some casing stuff, and then we'll probably just return whatever based on a selection or whatever. I can then return the appropriate function's return value. Now let's now get started with the vehicle, and in order to support our scenario, I actually just need to have that one function in there. Just like this. Then I can say that those code units implement vehicle, the vehicle interface. We'll do both of them. Just like this. And now what I can do, instead of calling the car, instead of calling the car, I can call the vehicle. So this is not going to work right away because the interface is not implemented. So let's publish this and run this, because I think now it's getting interesting of what we actually see happening when we run this code. Yeah, I should specify the startup page ID probably. And now I can run. Oh, I extended the customer list card. I want to do custom list. So let me just fix this so we can do faster testing. Startup page ID. Object ID was actually correct. I think the default one is 22. All right, actions, there we go. Now it says the interface is not initialized. What is this? So an interface has to be initialized before it can be used to invoke procedures on it. So let's create a procedure, get number of wheels or something, and this will retrieve the interface. And for simplicity, I will just raise the message in there. Then let's call it show number of vehicles. And then what I can do is, imagine you're calling this from a dependency or from somewhere. I can do my car again, code unit, car. And I can say show number of wheels and pass in my car. Now what happens is that this way the vehicle interface gets initialized and the runtime knows that actually we want to run the functions inside the car code unit. So let's run this with the debugger. And let's see. Oh yeah. So this is just the car code unit. It's uninitialized. And this is just, you know, go to definition. This is code unit. This is all fine. Now, if I go here and say get number of wheels, I'm actually looking at the interface. And I'm not sure if, yeah, it's actually, that's interesting. I never tried that actually. So in the debugger, you already see that this is the code unit car. What's inside of that variable, basically. And if we go to definition, we end up in the car code unit instead of the vehicle interface place there, because it doesn't have any code, right? So this is the most simple way to invoke interfaces. Basically, you define an interface. You say you give the code unit an implement, and then you can just assign it and call the interface. And that way you can, I think Vieco really described this in an interesting way. That way you can, how was it? Dependency delegation. I'm not sure what the correct term for this is, but you do not care about the implementation anymore inside here, because you're just saying, well, give me any code unit basically that implements my interface. And wait, nobody told me that I have a typo here. Did I? Vehicle. I'm not even sure. Actually, I have an extension for this, so no, there's, okay, never mind. Any code unit that implements my interface can be passed in here. So I just need a procedure which returns the number of wheels. How it manages to identify the number or the return value in general does not really matter in that scenario. So yep, let's get more advanced here. Now, I mentioned enums at the beginning, so let's create an enum and see how we can use interfaces with enums. Yeah, just sometimes it's vehicles, rename, and I'm never sure if I really need that blank value at the beginning, but come on. All right, so now we have this, and next one would be the car, and yeah, not truck, but motorbike, but that way I have the motorbike. All right, now the old way, when we had just option values or whatever, we could, to call this, would be to go in here in the page extension, create a case, and then depending on the selected enum, I can then call the correct function. Let's actually, I want to create a quick page for this, because it would be easier to show you and to demonstrate how it works with enums. Some setup page, just for the sake of it, and we won't even do table right now. It's just just to demonstrate, I will fake it as much as I can. It's quicker. This would be the equals enum vehicles. And now I can say it will just be the field. And here we have the vehicles. So imagine you have a setup table where you can select an enum value basically to determine how the system will behave. Now let's adjust the launch configuration so we end up on that page immediately. And let's move that over. All right, looks about good. Well, I won't do anything for now, but this is now what we have. We can select the vehicle and then we can run the action. So let's build in the missing functionality. So the old way of doing this would be case vehicles of this would be the old way of doing this in general. And then now we can do, we can delegate this to the function and say, well, I don't know exactly, maybe this function is in a dependency. I don't know exactly what will happen, but I can build some logic around it and then just pass in the right code unit, which I need. And let's see if that works correctly. I can say car, or I can say motorbike U. But this could be quite a number of places throughout the system, especially if I want to extend an enum. If I now had my extension and want to build, like implement another vehicle, maybe a boat, which doesn't have any wheels, then I really need to extend all the places throughout the entire system. And I need to find and identify those places. So it gets messy. That's because we can do, or for that reason, we can do implementations on enums as well. Now it starts to complain about a few things here. That we do not have the implementation for those values specified. That's something we can fix real quick. And IntelliSense sometimes isn't really helpful, but you need to specify the interface and then the code unit name which you want to have assigned here. I never found this really helpful that you have two equal signs at the same line, but it's the implementation and it's just car goes to vehicle, because you can have more than one implementation used here, and then you need to specify them all at the implementation level for those values. Let's do motorbike as well. And now, well, this is the empty one has to be implemented. So let's just create an empty one. Empty vehicle. Yeah, we didn't add those functions to the interface. So that's basically the most simple implementation. You could raise errors like it's not implemented or whatever. And what you can do is you can define a, let's reload this because it's annoying. Come on, default implementation, there we go. And the default implementation for vehicle is my empty vehicle implementation. Now, whenever, and you can also do the same, by the way, for unknown value implementation. You can have a different one, you can use the same one, but you can specify this. And that's basically if, for example, an extension adds a third value, then that gets selected in the database, it stays there. And then the extension gets uninstalled and the value 3 is therefore unknown afterwards. And that's where this property kicks in. All right. Now back to the setup page. What I now can do is, I don't need any of those things anymore. Nothing. Oh, this was one line too much. I can now go ahead and just say show number of wheels, and I can pass in my enum. So I do not need to care about code units at all anymore. I can just pass in the enum directly, because the enum has the assignments of the code units in the definition. So if I do this, I get 0, car, 4, motorbike is 2. Let's also have a look at the debugger here just for curiosity's sakes. Yeah. You see, vehicles is car, which is the enum. And then when I assign it to the code unit, it becomes the code unit car again. So that way you can use that. And now if I were to extend the enum from another extension, I just need to have my enum extension with my new value and implement all possible interfaces the enum cares about. And if the creator of the original extension did manage their calls correctly, it will just work. You do not need to do like event subscribers to find all the places you need to care about. You just need to implement the interface with your code unit, and it works. Now this is probably the most common and the most straightforward use case there is for enum usage, and this is also the way I mostly use enums or interfaces whenever I have setup values or anything where I need to execute different logic based on the user's selection. I'll probably go with interfaces because it's just easier to call it. It's not, maybe not even that I need to extend so much or something on my own stuff. And also if I do PD extension, it's probably not even a scenario that users will that other developers will extend on my code. But it's just easier to manage and to call this. I don't need to have those cases, and I don't need to do like much logic, because it's just the engine, the runtime will care about all of that for me, and I do not need to implement that code all by myself. Now, let's look at some other use cases where it's also really helpful to do interfaces. And that gets a little bit now more complicated. So we will touch a little bit about on testing, test code, and what you can do to make your testing life a little bit easier. Let's see if I can come up with an example. Rename file. Let's see. Let's do some And really do not, like, this is just made up right now as we speak, as this is all live. I did not prepare this in any further detail. So let's do something like post invoice, just so I have something I can show, right? So imagine we have something like this, where we have the general ledger setup, or the sales setup, sales receivable setup. We have the sales invoice header. For the sales header, we have the sales lines. Now we want to obviously do a setup get. We want to do maybe some setup test fields. Test field. What fields do we have? And I really just, I'm just making up an example, right? So just so I have some tables I can reuse for this. So just imagine we have some setup. We need to check some preconditions. We need to make sure that everything's in order. Then we or let's actually do just create sales invoice. That's easier and not so complicated. Create sales invoice header. And I'm just letting, that's probably not gonna work. Just letting Copilot do its thing here a little bit, so I can create that exam. Set up due date. Let's just do something like this. And invoice header insert. True. And then we create the lines. Document type. And the unit price. And insert. All right, so this is the most simple example I can probably do with that. So with creating invoices. Now, what are the individual steps we're doing here? We are checking, we are bringing the database in the right state, throwing errors at the user if something's not there. We create the header, we create the line. Maybe, and just maybe, we want to do some validation afterwards. And this is not yet test code. This is just regular code. Validation of outcome. And we maybe want to do some logging. And then we maybe want to do some notification, like success. All right. So let's create some functions here, because one function should only do one thing, right? And this is now also touching a little bit on clean development, actually. So, do validation, something like this. This is perfect. Log, send notification. And now using David's extension, we can just do something like that. All right, we do not want to throw errors, so I will just leave them empty for now. But that way we have something we can work with afterwards. Now let's also extract those procedures. Create lines. Just does one line, but imagine it would create more. And then we also want to do create header. Something like this. All right, so now we do not even need the code comments anymore because the function names are just speaking for themselves. All right, and let's also extract this because this is, doesn't it like the comment maybe? Yeah. Get set up. Something along those lines. All right, now we have a function. We have dedicated the whole code into their own procedures. And now let's go ahead. Imagine, I want to test this. In order to test this function, you need to be able to, you need to prepare the setup. You need to satisfy everything that happens in that function. So you maybe need to create a customer with the right posting groups, and so all the validation on the sales invoice header works. And then same goes for the lines. You need to make sure that the validation actually is satisfied with what you created. So you need to create it in the right way. You'll end up creating log lines for that. There might be code in there that's also not happy about a certain state, has requirements. And then you even get a message. You need to create a message handler and all of that. So now imagine this would just be one interface. And let's actually create this. So let's do copy those functions into a new code unit. Or into a new interface, actually, interface. And that would be an InvoiceCreator. Something like this. Obviously, in an interface, we do not need any code. And we do not need local. And that's the interface. Now with that interface, we can now say, well, our create sales invoice code function retrieves an interface and calls the functions on that interface. Come on. Why can't I? All right. Now, just because it's easier, we can also say, well, our code unit actually implements the interface. What's not working? What's missing here? Oh, because, all right. Yeah, then we cannot do them local anymore, but I think I can do them internal. Yeah, that works. Okay. So now this gets a little bit complicated in terms of following the code path. I'm going through that interface to call my local functions, which are basically just, I could also call them locally directly. So why am I doing this? Now I can, in my test app, imagine I would be in my test app. Okay, I need to have the files renamed. Imagine I would be inside my test app. I can create a new interface, and I think vehicle will scream at me because I'm not sure if this is a fake or if this is a mock or if this is a dummy or whatever. But I can do a faked invoice creator, which also implements the invoice creator. Yeah, and code unit, sorry. And now I can say implement. And what I now can do is, for example, I want to create one fake invoice creator to just test if the setup works correctly. Or okay, different. I can call all of those procedures individually to test if they are working correctly. But if I want to test this one, I can create an implementation and just check if they were called. So I can create a bunch of global variables. Validation was called like this, and then just set them to true in here. Now, why should I do this? If, and this is the unit testing approach, I think, then I would also create getter functions for this to retrieve the values from my tests. And in the end, I'm in a place where I can call all of those functions individually from my tests, and then I can just see if this, maybe here is more logic. I mean, if there are ifs and stuff inside here, it might not be as obvious as it is here, and then I can see if this function, which manages the calling of all of those functions, behaves correctly. Right, so this is how this can be done. Now, let's go back a few steps. So this is for testing, and this is usually how I would do the testing, and then I can also just disable certain things. And for the regular, like for calling this from the regular code, you can just do an overload where this does not exist, and you just pass in the InvoiceCreator code unit, or in that case, you can even do, since we are at BC25 already, you can do create sales invoice this. And that way you can call the functions without parameters to just default to this implementation of that interface. So that way you can just play around a little bit with interfaces to make functions replaceable. And that's actually what would be the next step if I would want to, for example, let's go back one step where I had them all locally. Imagine we are here. And now, what if you want to give the opportunity to override those functions individually? Maybe I want to change the way notifications are sent. Then I can do an interface. Again, name. Wrong button. I can do create an interface. Notification sender, something like this, which has just one procedure. Send notification. Like this. And then I can say, well, just give me the implementation of how you want to send notifications, and I don't even care how they are sent. I just specify that, well, I would like to send a notification to the user here. And if you want to do notification bars, or if you want to do messages, maybe you want to send an email. I mean, there are tons of possibilities. Same goes for logging. You could do the same stuff for logging, and then you have a bunch of interfaces being parameters for the function. And then I think this is, I really need to link the video. I think there should be a recording from Tech Days where Vieko explains this in far better detail and than I could. This ultimately leads to the factory pattern, where you then pass in one interface which cares about all those implementation, and it gets really complicated. But and I do not want to go further into this on the stream here. But if you're interested, really check out what Vieko did and how he explained this. But the idea is really to give the opportunity to the caller to decide, to influence what will happen. It doesn't change the structure of my code, the logic. I will always say, I want to get the setup, I want to create headers, lines, do some validation, I will want to log, and I want to send notifications. But it changes what actually happens, like how that is executed, what is done in detail, like what is the actual execution underneath. So that way you can change that behavior. And let's see. Let me think of an example. Let's actually pull up the Explorer and see what interfaces we have in the base app, because that's always interesting to see how Microsoft actually applies those principles. So let's see if there is a good one. So this is mine. So the base application has a few, the system application has also a few. Maybe let's have a look at the mail connector. Oh, this is actually an easy one. So I'm not sure where this is used, but apparently there is an interface to reply, to retrieve mails, and to mark as read on emails. And this is actually this extends. So this is already v25 stuff where you can extend email, extend interfaces. So let's have a look at the base one. Where was it? Secret provider. There. So we can send, get accounts, show account information, register account, delete account. Right. So this really, and then at this point, you can probably change and implement your own email connection with your email service, whatever, and it will seamlessly integrate into the base app, because you can just extend on all of those things. So if we were to look at enums, there are probably quite a bit more enums. So let's have a look at the, oh, interfaces do not have an ID. Nice. There we go. Enum connector. Yeah, so that's even more interesting. That's probably in the system app. And then we have enum extensions, I suppose, from base email scenario. Where it, okay, this is the enum scenario and not the connector. So the wrong one. Let's see if we can find it. No, it's just email scenarios. But that way you can post them. Probably implement your own email connection of some sort. Arthur is asking why it's extending the email connector. Because changing an interface is a breaking change. That's the reason. So you cannot change an interface anymore. You cannot. You need to obsolete the entire thing and then implement a new one before version 25. Now with version 25 we can do extend, and if a code unit implements this interface, it has to implement all the functions from this interface and from the extended interface. So that way you can add new functions to it, and then whenever, like, everything that worked before will still work, because it doesn't care about those functions. And yeah, new stuff that's using the v2 will work in both scenarios, because you can afterwards you can cast it downwards into this. But I'm not as familiar with the new commands, so I cannot really show that comfortably right now. But I will probably do a follow-up stream when I've had my first use case for this, to really show you how that's working. Yeah, I guess that concludes what I wanted to show about interfaces for now. So let me know if there's anything else you would like to see about interfaces. Maybe I missed something, maybe I need to explain something in further detail or something. Just let me know, either in the comments on the recording, or just shoot me a message on Discord, on Twitter, wherever you like, and let me know if there's anything else I can show. And yeah, have a nice Sunday, and